Hey everybody, we're going to do a little lesson here on lesson 7-6, translating trigonometric functions. A lot of it's similar to what we've done all year long. So we're going to do all these types of shifts, the amplitude, when it goes up higher and lower, here's your midline, and then two above and two below. That midline, the period of 4 pi, how long it takes to finish one whole cycle of the graph, like you go from this high point to this high point. The phase shift pi over 2, that's right in here, pi over 2 to the right. So we're starting over there if you're going to move it pi over 2 to the right for our sine graph. And then the vertical shift, how much we moved the midline up for the graph to oscillate back and forth across. But let's get started on an actual problem. So just a reminder here, we're talking about sine. If we were working on our sine graph, we would start at 0. We would be at 0 halfway through and we'd finish at 0, and then it goes 1 high and 1 low. So your overall graph for just a plain sine would look like that. So the red one, the 2 sine, we're going to go twice as high and twice as low. Oops, back through 0, twice as low and back to 0. Then we would try that again. Twice as high, back through 0, and twice as low, something like that. So then when we go to the blue one here, we're still going to use the twice as high, twice as low, but this is going to move it pi over 2 to the right. So we're going to start over here, and we'll be back to 0, and we're going to end over here. We look at our distance out here, be ending out over here at pi over 2 past 2 pi. 2 pi is 4 pi over 2. So if you go 2 pi more to the right, that would be, or pi over 2 more, that'd be 5 pi over 2. And we got out here where we're going to finish. So we're going to start here. We're going to go twice as high still, twice back through 0, twice as low, and we're going to finish out there. So that was moving our graph, and when we came back this way, this would be back to twice as low. So that's your blue one. Now if you go to the green one, this green one right here, we are moving it pi over 6 to the right. That blue one should have been pi over 2 to the left. Whoops. If we took all that blue one off and instead move it pi over 2 to the left, so my pi over 2 to the left on that blue one should have been my negative pi over 2 here. It should have been left, not right. And then we should have started at 0, to high, back through 0, to low, and back to 0. So it would have finished right there at my 3 pi over 2. Okay, now let's go to the green one. So this green one, instead this time we're going pi over 6 to the right. So pi over 6, this would be 3 pi over 6 for pi over 2. And this would be 2 pi over 6. So this would be my pi over 6 right there. So we're going to start here. And we're always going to be 1 further to the right. So right here, past there would be, and then 1 past here, we're going to be back to 0. One of them, the pi over 6 here, would put us down too low. And then 1 mark past there would put us back to 0. So if we move this pi over 6 to the right, and you could calculate all those out if you want to, like this is 6 pi over 6 here at a full pi. So if you go 1 more, this would be 7 pi over 6 here. And if you went past the 2 pi, well, let's see, 3 pi over 2 would be multiplying both the top but 9 pi over 6. And then add 1 more, so this would be like 10 pi over 6. Reduce that to 5 pi over 3. If you wanted to go over here 1 more, 2 pi over 6 is 12, or 2 pi is 12 pi over 6. That's 2 pi, and add another pi over 6 into that. This would be 13 pi over 6 when you got out here. So that's moving the left and right and adding an amplitude. And then the next one is the number in front, this is called the frequency. It's how many times or how many cycles are there in our normal 2 pi period. So that frequency, if you do the period or your normal 2 pi divided by that 2, this will tell you the new period. So the period of this graph is going to be pi. It's telling you there's 2 cycles of the graph in our normal 2 pi period. So that in some ways that should correlate. If we said that there's that 2 right there, we need 2 cycles. Again, we're doing sine, start at 0, high point, low point, or 0, low point, back to 0. So if we were doing that graph just for a plain sine of x, it would look like that. And then if we wanted to do the 2, we have to have 2 of the cycles finished there. So let me get red here. So we need to finish 1 cycle right here. So we'll still start at 0. Halfway, we'll be back to 0 here. Halfway in between, we'll be at the high point. Halfway in between there, the low point. So we got to get, there's 1 cycle finished. And then we got to do the same thing. We got to be back to 0, high point here, halfway in between, low point there. So we've got 2 cycles of our graph in the normal 2 pi period. There's 1 cycle, and then there's the second cycle. So 2 of frequencies, sometimes they say angular frequency. So 2 frequencies where we normally would have just 1. Then we got to take that whole thing now and still do our transformations on it. So this dark blue one, we're going to take what I have there on the under the highlighters, and we're going to move it pi over 2 to the left. So if this distance is pi over 2 over here, so about here is going to where it's going to start this time, be back to 0 and finish right there. So we're going to be just going 1 high, back to 0, finish. And then when we do 1 more of those, 0, 0, we're going to be high point, low point, back to 0. Again, 2 cycles, 2 frequencies of the graph. If I can highlight these, there's 1 in our normal pi, because a period now is pi, like we figured out over here. 2 pi divided by this 2 frequency gave us our period of pi. And then the next one, we would be calculating, so there, the orange was 1 cycle, there was 2 frequencies or cycles in 2 pi. So from here to here was 2 pi. Then we are going to move it 1 more time on the next one. Gets a lot on the 1 graph. Could clear this up. And let's try to, again, if I'm just doing the sine graph as my reference. So I'm going to go back to 0, 0, high point, low point. That's the sine. And then we had the one where we were doing 2 cycles in there. So we've got a high 0, low 0. That would be 1 cycle. And then to get the second cycle in there, we've got to go high 0, low, back to 0 again to get 2 cycles in our 2 pi now, the frequency. And then now this time we got to move it pi over 6 to the right. Remember, this was 3 pi over 6 for pi over 2. So this is 2 pi over 6. That's just 1 pi over 6. So it's 1 dot to the right of each of my other ones. So I'm going to have this dot. So we're going to start there. We're going to be back 1 dot past. So we got to finish there. And halfway in the middle, we're back to 0. And halfway in between these two, I'm at a low. Half between these two, or this one was a high, this one's the low. So there's one after I move the red highlighter pi over 6 to the right. And now we're going to do the same thing with that next one. So I don't know, you might think it's a little confusing. It just takes a little, like so much math, just some practice, and you can get it. So then we would be doing 2 cycles there, the blue and the yellow highlighter. All right, if you understand that one, then there's a couple you can practice on. If you're in class, we will do that. When you get to example 2, so we've got our red being our sine of x. Again, how does that sine of x go? We start at 0, then we're at 0 halfway through, and we finish at 2 pi. So high at this point, low at this point. There's our normal sine graph. Now, if you're going to put it as a 1/2 here, that means, because it's like x over 2 is 1/2 times x. So when you go to work this one, we need half of our cycle. So when we get to our 2 pi on this next one, we're still going to, this blue, let me put it in blue. So we're going to start here. When we get to our normal 2 pi, we're only halfway done. So that means right here, we're going to be at our high point. So we're going to be up there, and we're going to be at our low point. See how that's just half of the cycle of the sine? So then if we went and continued out here, we'd be at 4 pi if I could have it long enough, because it's going to be twice as long as the original graph. So this blue one would look like that. And again, it's what the 1/2 does is it actually makes a period. You do 2 pi over the 1/2 because you multiply by the reciprocal. So your period now is 4 pi. And the 1/2 makes it take longer because only half of our frequency or half of our graph is done in the 2 pi. So what happens on this next green one? So if we go to this green one, I'll just use the highlighter here. If you go to this one, all they did here is they changed your amplitude to a 2. So everything's going to just be twice as high. So there are points there. Well, that was for my regular sine. Let's go to the highlighter. So I'm going to be twice as high there. Let's get this extra dot off here. Twice as high there, still 0, 0. And if we got all the way to the end, we would still be back at 0, but the twice as low right here is going to be down there. So if we do the amplitude too, that's going to look like that. And the last one, if you take the purple one, this +3 now is added on. So that's just, I'm moving the whole graph up 3. So one, normally it oscillates back and forth over the x-axis. So now we're going to have that midline up at 3. So we're going to oscillate back and forth over that 3 up there. But it's going to take, let's see, we've still got the amplitude 2 starting here at the high point. We got to be up 2, so that would be right up there for the high. Oh no, that's back at 0. So back at 0 right here. The high point. I'm looking at the wrong graphs again. Got to be looking at the blue one. So yeah, this would be up here. Remember, we're just doing half the cycle right here, and our amplitude is twice as tall. So that one starts putting all the pieces in the puzzle. Continuing from there, now they ask us to find all the key features. So my vertical shift is this one up. That's like we're going to move our midline. I like to always start with that. Then we don't have any horizontal shift. It would have to be like 3 times x, and this h here would have to have a number if we were going to move the graph left and right. We're doing cosine, so just a reminder, cosine is start at the high point. Here we're going to go through 0, the low point 0, and back to the high point to finish one cycle in our 2 pi period. Your basic cosine graph. Then if we're going to move it 1 up, we're going to start 1 up there. But then we also, in addition to that on this one, we've got an amplitude of 4. So If we're gonna, 1 is normal, then we would have to go 4 up for our high point. 4 below the midline, 1, 2, 3, 4. We'd go as low as this -3. We'd go as high as this up here. I think that should be 4 above the 1, so that would be 5 for where we start, because we're going to be up there. And then don't forget we had this frequency of 3, so that's going to be our phase shift period. Oh, no, it's going to change our period, sorry. So our period now goes from 2 pi to 2 pi over 3 that we have to finish the graph. So where's 2/3 of a pi? Here's a whole pi. Is that 1/3, 2/3, 3/3? So this would be your pi over 3, 2 pi over 3. We'd have to finish our cycle right there. So if we are going high, let me get a different color. High to halfway through back to the high, oh no, at 2 pi over 3 I need to finish. So that means I'd have to be at the low point right there. So high to low to high. And we're going to hit each of those. So now we're going to come through here, be the low, back through here to finish right there. And then I'm trying to get 3 cycles in before we get to here. So we're going to be then we're going to be the 3rd cycle over there. 3 cycles of the graph, each one of them being 2/3 of a pi for the period. The phase shift left and right, we don't have any. The frequency being the 3, amplitude being the 4, and the vertical shift being 1 up. So there was 1 of the frequencies right there, 2, and lastly 3 in our normal 2 pi period. All right, let's see what we've got after that. What's going on here in this one then? So the negative in front is going to flip it. Okay, we got the whole midline moved down 2. So our midline's down here that we're going to oscillate back and forth across. We're going to flip it on the sine. Remember, sine normally goes from starting at 0 and goes up, back to 0 and finishing the cycle. So high point, low point, back to 0. No, start at 0, high point, back to 0, low point, back to 0. Like that. And this time we have a -3, so it's going to flip it, this -3. So we're going to go down instead of up for the first direction. And we're going to be, let's see, if we got to go down, move the midline down 2, then it's 3 below and 3 above. So I'm going to go as high as the 1, as low as, let's see, I'm down 2 and I'm going to go 3. So this is -5. And then that's just kind of give me an idea where I'm going back and forth. We're going to go down. Oh, and then I got this 1/2 here. So my 2 pi over my 1/2, because pi over 2 is the same as 1/2 times pi. So this is when I divide by half, multiply by 2 instead. And that's going to give me my period to be 4 pi. So we're going to be out there only halfway done with a cycle again when we get to the 2 pi. So if we're going down, maybe at my low point here, and back to my midline here to only have half of my cycle done at that point. So there would be, and then we would go up as high as that and out here, be done at the, instead of 2 pi, to be done out there at 4 pi. So I think we got all those in there. Reflect it. So it's going down instead of up for the sine. 3 for your amplitude, above and below the midline. Your period of 4 pi or finishing a half of a cycle. In our normal half of a cycle, in our normal 2 pi time frame. and then move the midline down 2. So all of those I think we got in there. You can always throw it into Desmos, take a look and see. It does a pretty nice job. So then they just start trying to give you an example of a problem where you're going to use it. They give us the graph, and we're trying to come up with the equation. So first of all, I'll just go with the D. It's oscillating back and forth across the x-axis, so that's going to be 0. We don't have to move it up and down. The C, do they tell us which graph to use, sine or cosine here? I don't see that it does, so I'm thinking it looks like the sine that they're wanting us to look at, which if we looked at it from there to there, that would be 1 period or cycle of the graph. So to get your C, we're moving it 3 to the right, if that's our starting spot. See how normally we would have been here, and you go up. So we're starting from there where I highlighted in blue to get that cycle of the graph. Then the B, remember for B, your frequency, that's 2 pi over your period. And so how long did it take to finish this cycle of the graph from here to here? I don't think it's an exact number. It looks like I would something like 9.5 from the story. Assembly line stamps log on graph models the stamp height from the at time x seconds turns on. What's an equation that models this? So we're gonna have to estimate to get that number. If it's just past 9, I'm thinking that could be 3 pi's would be just over 9, right? So let's use 3 pi for the period. So if we have 2 pi over 3 pi for the period, that would just give us a 2/3 for that B value. So this 2/3 right there could have been a whole number that we would have just had a pi left, like instead of using this 3 pi here. So I'm estimating that because I don't see anything in the story that tells us what that's going to be. And then my amplitude out in front of the sign there, I always liked it an extra set of parentheses in here. So you know all of that's actually inside of the sign. And then my amplitude, how high is it going above and below? It looks like it's just going one high and one low, so we don't need to worry about an amplitude in front of that. So the equation, again, you could actually, for that equation, you could actually come up with a little bit of a estimate, but at the same time, throw it in Desmos and see if it looks like what we had to start with. The next one, there's your try it. I could do that sort of quick. That looks like a cosine graph, high point, low point, high point from here. So if I did the cosine, it's going across the -2, so I got to move my midline down 2. I don't have to move the x left and right. It's finishing the cycle in 2 pi, so I don't need a frequency. I think that's all we need there then, a cosine of x -2. That's a lot simpler, and if you can understand that one at least, those ones we did before that, throwing all of the different transformations, that's quite a bit. So now they're trying to show you again in a real life situation where you might use this. If I wanted to use this cycle of that graph, there's my cosine. My midline looks like it's right through there. We could get it more specific if you wanted to, using a low point and a high point and calculating it. I'm just going to say it's the 60. Move your midline up. Move the whole thing to the right to the 7 to get your frequency. How long does it take for that period from between those 2 points from 7 over to here? Wait, yeah, 4, 5, 6, 7, 8, 17, 19. So from 7 to 19 finishes a cycle. That'd be a period of 12. So in here, 2 pi over 12 to calculate your frequency, a pi over 6. And my amplitude out in the front, from my midline of 60, how far does that go up? Let's just use the 90. And we'll use all the way down to, from the 60 down to, I don't think I've got those split evenly then. Let's say it's 55. down to 40. That would be, well, not 30, 40, 50, 60 to 90. If I use 60 to 90, that's 30. So I need to go 65 is what I need to do to get this split evenly. 65 to 90 is 25, and 65 to 40 is 25. So let's put a 65 out here for this midline to make these come out evenly, and then that would make a 25 sort of thing. So just kind of making it work. But that's just an example of where you might have to use that equation. And that is that's a pretty long, quite a bit of stuff packed into that one lesson. Hope that video helps you a little bit.